Now we are going to talk about the third principle or the third theorem about the product of a constant function. Product of constant function, product of a constant and a function. That is, the function should be type the product of a constant and function. So according to the theorem, the derivative of such functions should be like the constant comes out and d by dx only applied to the function depend upon x. And we can write f dash of x. So the rate of change of y with respect to x of this type of function is equal to that k comes out, that it doesn't depend upon the constant function and only calculate its value over the function that depends upon x. So we will have to prove it. So we'll prove it by using the definition method. So proving this third theorem, so writing the function first, then adding a small change, in the next step we have to find the difference of these two functions. Taking common, and we will get this figure, and here delta y, then dividing by the change on both sides. The next step is taking limit on both sides. So here we can write limit delta x approaches to 0 as we all know the laws of limit. The limit doesn't apply on this factor but applies to this factor only, this whole factor. So this will come out here in this type, delta x approaches to 0 and the factor contain delta x. Now we know that this factor with the limit is the rate of change, is the definition of the rate of change. So this we can write k with the d by dx of the function f of x. This is the function f of x. So eventually we will prove this, that we will come out with the expression in the end with this, and we can write this in this form in the end as well. So here we will prove this product of the constant function theorem. Now we will take an example. So let's take function 8x to the power 3 by 2. So we should apply the product function formula. So d by dx of 8x3 by 2. Here 8 comes out, and d by dx x to the power this. Now we will apply the power rule, that 3 by 2 comes down, there should be decrease in the power, and then the rate of change of this with respect to the x. So solving out this, we get 12, and this is 3 by 2 minus 1, we get half, and this is 1. Eventually this is equal to, the answer is 12 square root. So this is the answer by applying the theorem. So it is pretty simple to find the derivative of such functions by applying theorems. Theorems makes our work more easier than finding the derivative with the use of the definition or by the first principle. In the next video, we will talk about some other theorems that will help us to find the derivative of some other types of function. Stay tuned. Goodbye.